Do the following graphs represent one-to-one functions? Part A, happy face parabola. Part B, sideways parabola. Part C, a circle. Now let me just remind you about one-to-one functions. First of all, you must make sure that your original graph, your original guy, is a function, right? Just to be a function means it passes the vertical line test. After you've established that, then you can ask the question, is that function one-to-one? Is it a one-to-one function? And so after you've established, yes, it passes the vertical line test, therefore it's a function, then you determine if it's a one-to-one function just by seeing if it passes the horizontal line test. So part A, where our happy face parabola, this is indeed a function because it does pass the vertical line test. And what does that mean? To say that it passes the vertical line test, well, that means that there is no vertical line. There is no vertical line that crosses this graph in more than one place. So as many times as you draw a vertical line up there, you'll never be able to come up with one that passes through this happy face parabola in more than one place. And that means it's a function. It's an f of x. Okay, but now let's answer the question. The question was, is it a one-to-one function? It is not a one-to-one function. And why is that? Because it fails the horizontal line test. So let me review. To fail the horizontal line test means that there is no horizontal line that crosses the graph in more than one place. So look at that picture. I can come up with a horizontal line that crosses that happy face parabola in more than one place. It fails the horizontal line test. So once again, the deal is this. In order to be a function, that's the first thing you have to determine. It has to pass the vertical line test. No vertical line crosses a graph in more than one place. Then you can go on to the actual question, is it a one-to-one function? Well, now you do the horizontal line test. If it has no horizontal line that crosses the graph in more than one place, then yes, it would be a one-to-one function. Let's look at the next example. This dude, the sideways parabola, he's not even a function, much less a one-to-one function. He's not a function because it fails the vertical line test. You could come up with a vertical line that crosses the graph in more than one place. If it's not a function, we won't even ask if the darn thing is a one-to-one function. So the answer to this one would be no, it's not. It's not a one-to-one function. It's not even a function. Let's go on to part C, the circle. Again, the first part we need to determine, is this a function? And then we'll ask if it's one-to-one. This is not a function. It's not a function because it fails the vertical line test. I can come up with a vertical line that crosses that graph in more than one place. So we're in the same situation we were for part B. We won't even ask if it's a one-to-one function. You know, I'm starting to wonder if there are such things as one-to-one functions because none of these met the qualification to be a one-to-one function. So my answer to you when you ask that question, are there functions that are one-to-one at all? And my answer to that is yes, there is. And I'm going to do an example for you of a one-to-one function. Look at this picture. Here's my y-axis, my x-axis, and here's my function. Look at that. That guy, he passes the vertical line test, right? There's no vertical line that crosses that graph in more than one place. So that is a function. In addition to that, now I can ask the question, is he one-to-one? Well, yeah, he passes the horizontal line test because there's no horizontal line that crosses that graph in more than one place. So this function that we've drawn is a one-to-one function.